finding the volume of the solid generated by revolving the region bounded by y equals x cubed, x equals 0, and y equals 8, about the line y equals 8. So first of all, we need to get the bounded region. So I'm going to focus on this first. I'm going to focus on the region bounded by y equals x cubed, x equals 0, and y equals 8. So we'll go over here and we'll graph y equals x cubed. That looks like this. Then we'll graph x equals 0. What does x equals 0 look like? Straight up and down line at 0, right? So it's the y-axis. Okay, so there's x equals 0. And then y equals 8 is a flat line up at 8. So the region bounded, the region in question is this. Okay, so then we're supposed to take that region and revolve it around the line y equals 8. Okay, so we're going to take this and there's the line y equals 8, so we're going to revolve it around there, right? And all the way back into the hallway, too. Okay, so I've got a visual aid here. So this is supposed to be the bounded region. See it? We're going to take it and we're going to revolve it all the way around, right? So here's where it started. Comes up to here, but then I meet the paper so I get stuck. So now I'm going to go backwards through the hallway. Okay, so you get this 3D figure. Does anybody want to say what they think it looks like? Yes, Nick. Kind of a hemisphere, good. Anybody else have a different picture of it? I was thinking half a watermelon. Okay? So since I think it looks like half a watermelon, I brought a watermelon. I brought aluminum foil, the knife for safety.
Cooking with earlier.
Should have brought a chef hat. Okay, so let's see. How do I want to slice this? Okay, so this is what I've got, right?
Yeah.
You see it? It's not big enough, right? The middle is supposed to be there, so it's not big enough, but you get the idea, right? Okay. so what do I got to do next? I got to find the volume of that thing. Somehow I got to find the volume of this, right? Okay, so what I'm going to do is I'm going to slice it again. So I have to find the volume of this entire thing. But instead of finding the volume of the entire thing, I'm just going to slice it up. And I'm going to find the volume of this first. And then I'm going to cut off another slice and find the volume of that. And then cut off another slice and find the volume of that, et cetera, right? And add them all up. Sound familiar? Okay, so our first job is to find the volume of this. So what shape is this? It's cylindrical, definitely. Now, it's not an exact cylinder because, well, why is it not an exact cylinder? Yeah. The edge is curvy. There's another reason. That's a good reason. Yes? Yeah, this circle is a little bit less than that circle, right? The circles get a little smaller. So a technical perfect cylinder would be the same circle on the top and bottom, but this is a slightly smaller circle on the top than on the bottom. But we're not going to worry about that. We're just going to pretend that this is a perfect cylinder, and we're going to find the volume of it. Okay, so how do you find the volume of a cylinder? Pi r squared times h. Remember, the general formula for the volume of something is capital B times h. But in this case, the capital B, the area of the base, is pi r squared. So that's pi r squared times h. Okay, so I told you there were going to be a bunch of slices, right? So when we were doing area, we drew a representative rectangle. So now we're going to draw a representative cylinder. So I chopped off this first cylinder, but then I'm going to draw one in the middle. So chop, 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 right? And here's the one in the middle. So that's supposed to be going back through the wall, right? So I'm very horrible at 3D pictures, but I'm going to attempt this anyway. I'm going to try to make it look like it has some thickness to it. It's not good. It's embarrassing. I'll be posting this for all to see in the video. But anyway, that's... So I just tried to draw that, right? You with me? So there it is, sitting there. So I got to find the volume of that. So that's pi times radius squared times h. I'm going to start with the h. The height is a small distance going that way. So that's dx. Because you all knew I was going to go infinitely thin eventually, right? Why not just go cut to the chase right away? Cut to the chase. All right, so then the radius is the trickiest part. It's the distance from there to there. You see that? The radius goes from the center of my cylinder out to the edge of my cylinder. Okay, so let's pretend, this is not accurate at all, but let's pretend that that point right there is 2 or 3, 2. Let's go with that. Again, it's not accurate. I'm just making that up. I'm just making my point. Okay, so if that's 3, 2, how big is this radius here? Yeah, I heard it. 6 is correct. Because this distance is 2, right? Because I plot 3, 2. So that distance is 2. But then this distance is 8, because that's the line y equals 8, right? Everybody on board with 8 minus 2? This is critical. This is the hardest thing. Is everybody okay with 8 minus 2? All right, but in general, that's not going to be a 2. That's going to be a y, right? So in general, this is 8 minus y. Because I'm going to change. Yeah, go ahead, Ashley.
How do you know that y equals 8 is the point of the radius?
I don't totally understand that question.
Like,
All I know is that I needed to find this distance.
oh,
Because I revolved. Okay,
okay.
did,
Okay, yeah.
you're good?
Yeah.
All right. So I needed to find that distance. I knew this was 8, and then in my example, that was 2.
Okay.
So that's why this is 8 minus the 2. But then in general, this point's going to move, so this y will keep changing. So in general, it's 8 minus y for my radius. Is that good, Gabby? All right, so this is just the volume of one of these things, right? So I'm going to have a bunch of them. So I need to add them all up. And I at least need to mention that, I mean, this is routine at this point, right? But remember that slice of watermelon wasn't a perfect cylinder because it had curved edges and it had a different circle on the top and the bottom. But all of those problems are eliminated when the cylinder gets infinitely thin. Because then the top of the circle is identical to the bottom of the circle. And there's no curved edge because it's infinitely thin. So that's why I went infinitely thin, and that's how I'm going to get exact volume. All right, so now all I need is these two endpoints. Should they be x's or y's? They should be x's, because this is, the dx makes that decision for us. Since this thickness here, that height was dx, we chose to put a dx there, and that made the decision that our variable was x. And that's why these are going to be x's. So we go with the shaded region, and the smallest x goes on the bottom, and the biggest x goes on the top. So the smallest x is 0, and the biggest x is right here, which is the intersection between our two curves, right? The intersection between y equals x cubed and y equals 8. That's a really easy thing to solve. You just put an 8 in for the y, substitution, and then x is 2. So that tells us that this point is the point 2 comma 8, which we probably already knew. So then that makes this 2. Because the shaded region goes from left 0 to right 2. There's one more issue, right? This y is not good to leave because I've got mixed variables in my problem. So I need to change this into something. It needs to be the y value, but it needs to be a formula for y that has an x in it. Well, we have a formula for y that has an x in it. It's x cubed. So to get this height, you cube the x. That's why this wasn't accurate, right? Because that's not the correct y. It's not the 3 cubed. But this is the 2 cubed, right? So to get the y, you take the x and you cube it. All right, so that's the integral from 0 to 2 of pi times 8 minus x cubed squared dx. Now we got everything set up. Okay, now to calculate this, we're going to need to FOIL this out. The pi is just a constant, so I usually move it in front of the integral. So that's pi integral 0 to, and at the same time I'll FOIL this out. That would be 64 minus 16x cubed plus x to the 6th you take the antiderivative. So that would be 64x minus 16x to the 4th over 4 plus x to the 7th over 7 from 0 to 2. And don't forget at the end you're going to multiply by pi. So then that's 64 times 2 minus 16 times 2 to the 4th over 4 plus 2 to the 7th over 7 minus 0, right? (64 times 2 is 128. I'm staying strong. I'm trying to do this without a calculator. This 4 will cancel with 2 of those 2's. So we have 4 times 16, really. So that's 64. 2 to the 7th is 128, I believe. Let's see, 2 times 2 is 4, times 2 is 8, 16, 32, 64, 128. Yep. So there, I'm good. 128 minus 64 is 64. So I guess I gotta put 64 in sevenths. So 448 sevenths. Taking big risks here. Embarrassing myself. But I think I'm okay. So that's 320 pi over 7. Am I doing okay? Yeah? Yeah. Ah, yes, this should be a plus sign. Thank you very much. So, (576 pi over 7). That's our second try. How do we feel about that one? It's been a year, but that seems more familiar to me. Yeah, 576 pi over 7 is what I got on my notes, so I think we're good. Okay, let's see. Try another one here. All right, so this time we're going to find the volume of the solid obtained by revolving the region bounded by y equals x squared, y equals 9, and x equals 0 about the y-axis. Find the volume of the solid obtained by revolving the region bounded by y equals x squared, y equals 9, and x equals 0 about the y-axis. So I always start with the bounded region. So this is what we're focusing on first. The region bounded by y equals x squared, y equals 9, and x equals 0. So y equals x squared looks like this. Y equals 9 looks like this. And x equals 0 looks like this. So that's a little bit awkward because we have two bounded regions, right? We have this and that. So let me amend the problem and say the region bounded in quadrant 1. Okay, so that means now I just have this bounded region. And this time I'm going to revolve it around the y-axis. So here's my y-axis. So I'm taking this and I'm revolving it this way. That's different than last time. Last time I was revolving this way, right? Around, up and down. This time I'm going side to side in my revolution. Okay, so that's a key difference. Because when I revolve this way, circles are created from the side, right? So because of that, I wanted to slice off the circle on the side. This is different. This time I'm revolving this way, so circles could be seen from above. And because of that, I want to slice off the top. Okay, so this time my slices are going to go this way. Slice off the top first. So my cylinders are created here. So again, there's my representative cylinder. You with me? Everybody okay? All right, so I got to find the volume of that cylinder. So that's pi r squared times h. This time the height is a small change up and down. So this time the height is dy. That's a critical decision right there, right? That means everything has to have a y. That means when I integrate, I need my bounds to be a y, et cetera, et cetera. Does everybody see why it's dy? Because the height is going up and down. All right, so of course I don't just have the volume of that one, I have infinitely many of them. Now we just casually, almost flippantly say, we're going to add up infinitely many of them. Like, oh yeah, who cares? But that's a big deal, really. We're adding up infinitely many things. But it's not now. We just do it. Okay, so then the radius. That's the hardest part, right? So the radius goes from here to here. So I'm going to make up a number. It's not going to be accurate. Let's say this point is 4, 3. If that point is 4, 3, what's the radius? It's 4. If you plot 4, 3, that just means you went over 4, and then that distance is 4. So in general, if that point was an x comma y, the radius would be x. Is everybody okay with the radius? Okay, then my bounds need to be y's. So that means the bottom of my shaded region to the top of my shaded region. That's pretty much given to us. That's 0 to 9. Then we need to translate this x into an equation that has a y in it, because everything is y's. So we need a formula that'll give us x. And it's on this curve, y equals x cubed. So sorry, not y equals x cubed, that was the last problem. It's on the curve y equals x squared. So I need to solve this for x. X equals the positive and the negative square root of y. So we're going to use the positive half of it, right? That's the positive square root of y. This is the negative square root of y. So x equals the square root of y. So then I can come over here and replace x with the square root of y. So this is the integral from 0 to 9. I'll go ahead and put my pi out front, because I always do that, times the square root of y squared dy. Is the watermelon in the way of this problem? Okay. So then when you square the square root of y, it goes away, right? So you've got pi times the integral from 0 to 9 of y dy. Then you can take the antiderivative. That's 1/2 y squared. We're going to calculate that from 0 to 9. Then you plug a 9 in, plug a 0 in, subtract. So that's pi times 1/2 times 9 squared minus 1/2 times 0 squared. So 81 pi over 2. I have in here that I'm supposed to remind you. So you must need this identity on the homework. So this is a reminder that tangent squared x equals secant squared x minus 1. So I don't recall. There must be some homework problem you have that you need that for, so there it is. Okay, so now moving on to example 3. We're going to do y equals 4 minus x squared, y equals 0, and we're going to revolve about the x-axis. So at this point, I'm not writing out the full question, right? So what does the full question say? Find the volume of the solid obtained by revolving the region bounded by those two curves about the x-axis. You with me? Whenever I say that, I think of the movie Night and Day. Have you ever seen the movie Night and Day? With me? Without me? With me? Okay, so anyway. So y equals 4 minus x squared looks like this. Upside down parabola. Y equals 0. Looks like this. So remember, you're supposed to ignore the y-axis because it wasn't mentioned. So here's my region bounded. I'm going to revolve that down this way around the x-axis. What does it look like? Flying saucer? Advil? On a much smaller scale. It's kind of squishy. Okay. All right, so when we revolve this way, do we see circles from the top or do we see circles from the side? We see circles from the side, right? So that means that we need to slice it this way so that when we look at our slice, it's circular. If we sliced it this way, it would be more of an oval because we're not going like that. We're not seeing circles from above, so we can't slice it this way. We have to slice it this way. Okay, so I need to draw a representative cylinder. There it is. Try to do it 3D, but I'll fail miserably. That's why I brought the visual aids. So now I need to find the volume of that. It's a cylinder, so it's pi r squared h. What's the h? dx, right? This is critical. Is everybody okay with the height being dx? Okay, so then we got to integrate from that point to that point, from the left to the right of the shaded region. So we got to figure out when 4 minus x squared hits y equals 0. So we'll solve 4 minus x squared equal to 0 for that. So you could just add the x squared and then take the square root. So x is positive negative 2. So this is going from negative 2 to positive 2. Certainly can't have an r in my problem because everything's supposed to be in terms of x's, right? So now I gotta work on finding the radius, which I think is the hardest part of it. So the radius goes from there to there. There's my radius. So if that point is x comma y, what is the radius? It's the distance up and down from the axis to the point, right? So that's the y value of that point. So I'm going to put a y in place of my r squared. So everybody okay with the radius being y? Are you sure? We've got plenty of time. Is everybody okay with the radius being y? Yes? Yes, I can. I can say y. All right, so this is, I like to make up numbers. So let's pretend that that plotted point was negative 2, 7. So that would mean I would start here at 0, 0, and I would go backwards 2 and then up 7. So that makes that distance 7. So it's the y value. The only reason I'm using y is I don't want it to be a specific number because I have a bunch of cylinders that I'm finding the area of, or the volume of. And so I've got a bunch of different radiuses, so I need a formula for my radius rather than a specific number. And then this says, okay, go ahead and run your x from -2 to 2 and find all of those possibilities and add them all up. Good. This is still not fabulous though, right? Because I still have two variables in my problem. I still have, this was bad because I had an r and an x, and this is bad because I have a y and an x. So I still need to get rid of the y somehow. But the y is 4 minus x squared. So I can calculate that. So this will be -2 to 2, bring my pi out front, 4 minus x squared dx. Then I gotta FOIL that out. So it's 16 minus 8x squared plus x to the 4th from -2 to 2. So I just took 4 minus x squared, multiplied it by 4 minus x squared, and I got that. Oops, I did something wrong, right? What did I do wrong? I acted like I had already taken the antiderivative, even though I just FOILed it, right? And that happens to you guys too, right? You're in the middle of the problem and you're like, oh, I never took the antiderivative. So watch out for that. Yeah, exactly. And you scratch it out and you throw the paper across the room maybe, depending on what time it is. Okay, so then you take the antiderivative, so that's 16x minus 8x squared over 3, 8x cubed over 3, plus x to the 5th over 5, from -2 to 2. Multiply that by pi. Then plug 2 in, plug -2 in, subtract. Maybe I better do that over here. So I got my pi, and I am plugging in 2, so that would be 16 times 2 minus 8/3 times 2 cubed plus 1/5 times 2 to the 5th minus, plugging in -2, 16 times -2 minus 8/3 times -2 cubed plus 1/5 times -2 to the 5th. So then I've got 32 minus 64/3 plus 32/5 minus -32 plus 64/3 minus 32/5. So that's 64 minus 128/3 plus 64/5. Oh, this is a good time to make an interesting point. If it's non-calculator on the AP test, you can stop here. Because this is equivalent to the correct answer. This is the correct answer, right? As long as the calculus is done, you can leave this as your final answer. They do not care if you know how to add fractions. They don't want to grade it. Actually, I don't want to grade it. So I'm happy when someone stops here, right? When I'm in Kansas City, I'm grading. I'm really happy when someone stops here because then I don't have to. But the problem is if you go and you make a mistake, then you lose the point for the answer. So it's safer just to leave this. Okay, anyway. So now I need a common denominator. I'm getting bored at this point myself. So maybe I got this down here somewhere. Oh yeah, that's over here. Absent-minded professor. Now, all I know is that the end is 512 pi over 15. So we're not going to practice our fractions today. I know you're upset.